underlying structure to this data that hasn't yet been found or hasn't been seen yet. And so, you know, if there is, what does this grouping tell us, right? And so that's kind of the question that I wanted to answer, and that kind of led to the approach which you're going to see today, right? And so for the remainder of the talk, what I'll do is I'll first kind of try to reveal the underlying structure inherent in this data set, and I'll show you how I go about doing that. And then what I'll do is I'll use that information to cluster New York City neighborhoods into 4 different categories or groups. And then what we'll do from there is we'll try to find out what do those clusters mean, or what insight can we gain from those groupings, right? And so first off, this is kind of, if you want to reproduce this work, this is where you can go and download the 311 data, kind of a caveat there. This was only from 2014, so you can filter it, and also only includes 311 complaints from New York City. So actually, if you go through that data set, there are actually 311 complaints that happens from the suburbs as well. So only New York City and only 2014. And then if you, later we'll see kind of that I plot this out on a map to make it more relevant and more intuitive. And this is where you can actually download the shapefiles to do that as well. And so let's dive right in. I'm not going to step through all the code. I'll just kind of give you a quick summary of what I've done here. So this is the data. We read it in. What you find is that some complaints are coded uppercase and lowercase, and you want to aggregate those together because they're actually the same complaint. So we switch everything to lowercase. What we also find is that some of them are pluralized, and so we remove all the S's to make things uniform. And then also we find that there's some different kind of punctuation marks in here. And so we make that uniform as well, make sure that when we do our counts that all of this data is reflected in the correct bins. And then also we kind of group some similar complaints. So if you go through this data, you'll find that there's about 4 different complaints about street signs, and they're kind of funny to look at. Like there will be street sign dangling, or street sign falling on the ground, or something like that. And so we just said we're just going to change all of those to street sign complaints, right? And the same thing with fire alarms. There will be like fire alarm update or fire alarm not working or something like that. And I think there's 4 of those as well. And so we're just going to standardize that and say that that's a fire alarm complaint. And then also what you find is the zip codes are also not standardized. So in some cases there are 9-digit zip codes, and in some cases there are 5-digit zip codes, and in some cases there are no zip codes. And so what we do there is we say if there is no zip code, we ignore it because we're trying to figure out something about geography. And if it's a 9-digit zip code, we just make it a 5-digit zip code. And so the primary method I'm going to use to kind of try to impart some structure to this data is called factor analysis. And what factor analysis does, as most of you I'm sure are aware, it tries to figure out some underlying latent variables or factors that give rise to some number of complaints that seem to track together, right? And so if you have, let's say to put this in a real context, you have 2 different kind of neighborhoods. In one neighborhood, you have always noise complaints and taxi complaints, and in the other neighborhood, you always have, I don't know, dangling sign complaints and fire alarm complaints, right? And so, but if you replicate that out over the course of the entire New York City area, you'll see that those 2 always track together, right? And so we say that there's some latent factor that gives rise to the variance in multiple variables that you see there, right? And so we do this factor analysis, and the way you kind of can interpret some of this stuff is you look at the factor loadings, right? And so higher numbers are better here. Anything above 0.7, 0.8 is typically a good value. In this data set, I actually get, out of the 5 factors that I calculated, 4 of them actually have loadings above 0.9, right? And so those are great loadings. You don't actually usually see values that high. And so what does that mean? That means there's kind of 4 latent variables or factors that are causing a number of these other variables to track together. And another way to visualize this, which may make more sense than kind of looking at the raw output, is kind of this heat map, right? And so what you see here, these are actually all of the different types of complaints that you see in the 311 data. And when you see the loadings are quite dark, that means those variables track well with that factor, right? And so this factor, RC3, as shown here, means that any kind of area that is defined by RC3 will typically have these complaints, which are kind of higher red color, right? And then we've also got kind of 4 different clusters, this one and this one, that also have high factor loadings. And so basically what this is telling us is there are 4 latent factors, and so we should probably use 4 cluster centers if we're going to try to cluster them and impart some sort of structure to this data, right? And so with that in mind, we're going to cluster it, right? So we're going to use a k-mean, and we're going to get cluster centers, or we're going to use the number of cluster centers that we found from the factor analysis, right? And so there's no great way, you guys may know, there's no great way to pick the number of cluster centers when you do a k-means clustering. There's no, like, cross-validation kind of works, but it kind of doesn't. There's no great way to tune the number of clusters when you do one of these clustering analyses. And so kind of a lot of way, or the main way that people decide if their number of clusters is correct is they just kind of visually inspect the data, right? And so, excuse me, here what we've done, or what I've done is I basically took the first 3 principal components and then I mapped the cluster assignments to those zip codes or to those neighborhoods kind of in eigenspace, right? And so this is a great way to try to visually inspect if your clustering is good, because as many of you know, when you do a principal component analysis, the first component explains the most amount of variance, the second amount, third amount. And so if you don't get some sort of separation in the first 3 dimensions, and you don't see that, as we see here, then probably it didn't work, right? And so as we see here, we see a blue cluster up here, kind of our black clusters to the right, and then we have a little kind of separation between red and green here. So this appears to have worked, and this is only in 3-dimensional space, but really we're in p-dimensional space when we're actually clustering across all the variables. And so this looks pretty good, pretty good. Questions about that so far? We're all following? Yes? Okay. And so kind of an interesting thing here that I ran across is that there's quite a few zip codes that don't actually have any complaints. There's no complaint for that zip code. And as we'll skip ahead here, if you look at the map looks full, right? These are all assigned to one of those clusters we developed, right? And so how can that be? Why did that happen? Because we would expect some of these to be colored in white or not colored, not assigned, if they have a missing value or no complaints. Well, it turns out that there are these things called vanity zips, and I didn't really know that they existed before I took on this project. Basically, a company or a building can buy their own zip code from the postal company, right? And so, for example, the World Trade Center, the Empire State Building, and kind of the funniest example of this is the Saks Fifth Avenue shoe department, not the building, just the 5th floor, which is the shoe department, has their own vanity zip, as it's called. And so that's kind of why we don't see it here, because you don't see a speck kind of in the map, right? And so now we've done a few things. So let's summarize what we've done before we move forward. So basically, what we've done here is we've taken the frequency of counts by the different complaints in each zip code, right? And we've clustered them together. right? We did that. We chose the number of cluster centers based on a factor analysis, right? And so now we can start to look at these groupings on a map and see if they make sense, right? So now we're going to try to interpret our results. Because so far we've just kind of defined everything mathematically and it doesn't make any sort of intuitive sense. And so if we want to try to look at the clusters, we have cluster 1 here. That's mostly Midtown and Lower Manhattan. So that tells us that they complain about different stuff than the other clusters. Cluster 2, I'm calling this kind of typical New York because you see that this takes up kind of the largest area and it actually is the largest number of zip codes in New York. So I'm just going to call that a typical value because it includes more people in more area than anywhere else. And then cluster 3, if you see here, is this orange one, and that's mostly on the outskirts here of New York. So pretty far away from the city center and from Manhattan. And so I'm going to call those suburbanites. And then kind of cluster 4, we'll see this later, why I've named it the third world. But basically you're going to see that this is kind of Harlem and the Bronx, and then the interface between Brooklyn and Queens, right? And so what we've done here is we've basically clustered all these zip codes together, or these neighborhoods. Now we're trying to segment them and impart some sort of interpretable meaning to all of those clusters, right? And so if we move forward, we want to know, well, what does each cluster care about and how is that different than any other cluster, right? And so that's kind of what defines the segment names that I just gave to each of these clusters. And so if you do that, you can see that cluster 1, which was the Manhattan cluster, they care about true kind of first world problems. They care about complaining about taxis, noise, they make some complaints that all the taxis create smog, and stuff like that, right? And they try to get some sort of discount on their taxes. So nothing very serious, right? And so this is the type of typical, these are the complaints that track together in the Manhattan cluster. If we move on to the typical New York cluster, what we find is they complain less than everyone else. So the largest part of New York is actually kind of the baseline case, right? They're actually dragging the means down. And I should say, sorry, I should mention, when you interpret these numbers are z-scores, because before you run a k-means, you have to center and scale all your data, right? And so that makes things pretty interpretable, right? So positive numbers are above the mean, which is at 0, and numbers like this over 2, that means they're like 2 standard deviations above the mean, right? And so these people really care about complaining about taxis, right? Is the interpretation of that. Kind of the large swath of New Yorkers, they don't complain very much. That's how we can interpret this, where they complain less than the people in the other clusters. If we move on, the suburbanites seem to complain about kind of suburban problems, right? Like damaged trees and snow. In Manhattan, they remove all the snow, even from the sidewalks. In Manhattan, there are no trees. And so, these are very kind of suburban-esque problems when you live in New York. And then kind of why I called the last segment is the third world, and that's because the poorer areas actually complain about like real stuff, like stuff that you need to live, right? So heating problems, electricity problems, plumbing problems, they have like real problems. And so this is kind of what I wanted to get out of this analysis, right? We have a number of different neighborhoods. They have different complaints. There is some sort of underlying structure to this data, and we can see, or we have gained some sort of insight into the problems that those people who live within those neighborhoods face on a regular basis, right? And we see from these z-scores, this is not like an occasional problem. This is a very frequent problem, given that z-score. So this is what I wanted to find. It is inherent in the data, and more importantly, it kind of points to some big problems New York likes to call itself, a first-class city, but in fact, third world problems persist and thrive in a large portion of the city. And so, with that, thank you for your attention, and I'd be glad to take any questions.
Each vector pertains to a specific zip code, correct?
Yes.
How many were there in total?
How many different types of complaints?
No, how many different zip codes were there?
There's about 250, and then about 50 of them are actually bought by buildings. So there's actually about 200 real zip codes that people live in.
Okay, and then these numbers are the average for that dimension across all the vectors in a given cluster, correct?
Yes, as compared to the mean of all clusters.
Right.
Yeah.
But it's already centered around a zero mean anyway before you do the analysis, correct?
Right. Yes.
How long did it take to do this?
Depends who you are.
To be honest, this was probably my fastest project, and it's also actually probably the most complex in terms of its analysis. It's kind of like, I was in grad school for 4 years, and some projects just work, like every step works exactly as you expect it to, and then some don't work at all, and there's so much retooling and restarting. This was one of those ones that just like every step worked, which was surprising but also gratifying. So, to answer your actual question about how long did it take, about 3 days. Any other questions? Great, thank you guys.